Hello everybody, welcome to this video. And in this video, we're going to be looking at how to create density contour charts using Plotly Express. And a following video will look into density heat maps, which because both of them are actually very much alike in what they do and what you can create with it. Okay, so for this example, we are going to be using the iris dataset, and we already know that these are the columns for the iris datasets. The iris dataset is a very common dataset, everybody knows about it. And yeah, so let's go ahead and do it. So we're going to be using Plotly Express. So we've already imported Plotly Express here as px. We've imported pandas as pd because we're going to use pandas to read in the data, and transfer the data from a flat file, in this case CSV, into a data structure with panda data frame, which your code we can use in Plotly Express. Okay, so here we're going to use call density contour. Okay, and with density contour, first thing, with anyone that is familiar with Plotly Express, you're always required to specify the data frame. So in this case, we just call it data frame. Okay, there are a lot of things you can specify with density contour. First, you want to specify what's going to be on your x-axis. Let's say we want to specify the sepal width on our x. We can also specify our y, what we want on our y-axis. Let's say we want to see petal width on our y. Now you might ask yourself, why do you need to use a density heat map or a density contour map? Now the benefit of either of this is it helps you to see two-dimensional distribution in numeric values. Okay, remember your histogram just looks at distribution in one dimension, so also your violin and your box plots. But density contour and density heat map actually look at visualization in two-dimension. Sorry, distribution in two-dimension. Bare minimum, once you specify your x and y, you'll be able to just create a very basic contour chart. But we're going to specify much more, okay? But I just want us to start with this and see what we get. Okay, so it's spun up an HTML page. Let me bring that here so we can see it. Okay, so this is what we have here. We can see what the distribution in two-dimension actually looks like for this density contour chart. So you can see here you have your sepal width and you have your petal width, and you can see that they are primarily two major distributions here. Now there are a whole lot of things we can specify when it comes to density contour charts, so we're going to go ahead and specify those. Let me close this, let me expand this. Okay, so moving on, we can specify what we want on our z-axis, right? That's the benefit of density contour charts. Usually when you have visuals, if it has two axes, most times you are able to specify a third axis in Plotly Express. That's why you see a lot of charts actually allow you to specify not just your x, y, and your z. So for this, we can go ahead and specify that. Now you'd ask yourself, what are we going to do with this z-axis, right? What's it useful for? And it's useful for actually getting to know what should be fed into your istfunc attribute. So I'll show you what that is. So we have our visual here. Let me take this out, run this again, so I can show you how everything changed as we specified much more. Okay, put it back. Now for istfunc, say what function do you want to use to normalize the value specified on your z-axis, right? So there are various options you can specify, And I'll link the Plotly documentation here so you can go take a look at it. You can specify the mean, max, sum. You can also specify the average. Okay, so let's do that. Let's specify the average. Now for your ist norm, so this is pretty much the function you want to use to normalize your charts, right? So you can decide to look at probability density. You can look at density, you can look at percentage, and like I said, I'm going to link the Plotly documentation here so you can take a look at it. And we can give this a title, density contour of. So usually wherever you're able to use your Plotly density contour, you can also use the heat map interchangeably. And me personally, I like to use the heat map ahead of the contour charts just because it's easier to explain and it has a much visual appeal to it. So let me just show you what this is, and I'll show you what all these visuals look like as we make them. Okay, so now let me bring the documentation for density contour. There are other attributes we can specify here. So let me pull this up so we can all look at it. You can also specify the color. So let's do that. Okay, so now that I've generated a bunch of these, let me bring it here. So first, let me minimize this. Okay, so let's start from the very beginning here. When we just made a plot of sepal width versus petal width, just looking at the contours. Now what this just shows you is, it just shows you the distribution in a 2D plane, essentially. Now the difference between both of these is that here we specified something on the z-axis. Okay, so apart from just looking at here, we're just looking at the petal width, sepal width separately. In this part, we're looking at the petal length as an average as well, and looking at the distribution through that lens. Same here. Now in this point, this is where we had specified the color, so showing the distribution of sepal width, petal width, and using on the z-axis the petal length, and then coloring it. So this is what we had done so far, and in this case we also looked at the probability density as an output, so as a means of normalizing these values. So yeah, this is it. This is how you can create a density contour chart. It's not my favorite at all by any stretch of the imagination. It's not my favorite chart when I want to look at distribution in a 2D scale. I do prefer to use a heat map because that's just way more visual, and you can actually see that this is what's going on, and this is how all of these values relate with each other. So yeah, thank you. Let me know which you prefer, density contour or density heat map. I will make a video on density heat map. So thank you. I'll see you in the next video.